Hi friends, this video we are going to find an analytic function P+iQ such that P minus Q is given. So let that f of x z is the analytic function that is equal to P plus I times Q. So now I simply multiply the I on both sides. So I times f of z equal to IP minus Q. Now you take this is the equation number 1, this is equation number 2. Now add 1 and 2. One plus I times f of z equal to P minus Q plus I times P plus Q. Now, so clearly this is analytic function. Since my f of z is analytic, we know that, and 1 plus I is a constant times analytic function is again analytic. So this whole function you consider as a some g of z is equal to P minus Q plus I times P plus Q. You take P minus Q is U, P plus Q is I times V. So this is my g of z. Clearly g of z is analytic. Now I want to determine what is the g of z first. So what is U? U equal to P minus Q. P minus Q is the given problem, correct? Sin 2x divided by cos h 2y minus cos 2x. Now, so my aim is first I want to determine the g of z, then I can find f of z. So now I am going to use the Milne-Thomson rule. Milne-Thomson method. What is the Milne-Thomson set? So g of z equal to integral over ux z comma 0 minus I times u y of z comma 0 times dz. So first I want to take with respect to x and with respect to y I want to take derivative. So ux. So I want to take partially with respect to x. So u divided by v formula. So denominator is cos h 2y minus cos 2x the whole square. Numerator is you kept cos h 2y minus cos 2x as it is times the numerator take derivative is 2 times cos 2x minus sin 2x you kept as it is. So derivative of cos 2x is minus time 2 cos 2x. So you will get sin 2x. But because of here one minus will be there, that is why that minus then it, so 3 times minus, so it become minus. Now you club it cos h 2y minus times 2 times cos 2x minus 2 times cos square 2x minus 2 times sin square 2x divided by cos h 2y minus cos 2x the whole square. So clearly cos square x plus sin square is 1. So this guy equal to 2 times cos h 2y times cos 2x minus 1. The denominator by cos h 2y minus cos 2x the whole square. This is ux. Similarly, I have to find the derivative with respect to y. So now you take and I say this is the equation number 3. So now I take the derivative with respect to y partially. So you take sin 2x is same, that is simply you take as sin 2x. Then if you take derivative with respect to cos h 2y only, you will get sin h 2y times 2 divided by cos h 2y minus cos 2x the whole square. Now this is u of x comma ux of x comma y, this is uy of x comma y. So I am going to Milne-Thomson rule, g of z equal to u of integral over u of z comma 0. So we put x equal to z, y equal to 0. So first I will complete that one, then we will proceed. So from the equation 3 and 4, from the equation 3 implies ux of z comma 0. So you put y is 0, cos h 2y is 0 is 1. So 2 times 1, cos 2x is cos 2z minus 1 divided by cos 2y is 1 minus cos 2z the whole square. You will take minus 2 times 1 minus cos 2z divided by 1 minus cos 2z the whole square. So this square and this guy will cancel. So minus 2 divided by 1 minus cos 2z. This is u of x z comma 0. Next is from the equation number 4, uy of z comma 0. So whenever x equal to z, this is sin 2z, but sin 2hy, this is 0 is 0. So this is 0. Now g of z equal to integral over u of x comma z comma 0, that is minus 2 divided by 1 minus cos 2z times dz plus some constant c. Now I want to integrate. So I know that 1 minus cos 2z is 2 times minus 2 divided by 2 times sin square ez times dz plus c. So this guy will cancel. So integral over minus 1 over sin square, it is cosecant square times z dz plus c. If you are integrated the cosecant square, you will get it as cot z. This is our g of z. But in our problem I require f of z. What is g of z means? 1 plus I times f of z equal to our g of z. This is equal to cot z plus c. This implies f of z only I required, cot z divided by 1 plus I plus some other c1. This is our required function f of z. Thank you for watching this video.